1.7, the linear inequalities and absolute value inequalities, day 2. So our objectives today are we're going to solve compound inequalities and we're going to solve absolute value inequalities. So example 1 starts out with a compound inequality, and it's a compound inequality because we have two inequality symbols in it. So just think about it like this. If I only had that as my problem, that's what we did just on the last lesson. And so we know we would draw our line down through here and we would just solve for x. Well, because we have two inequality symbols, we're going to do the same thing. We're going to draw our line coming out of them. And our goal is to get x by itself in the middle. All right? So if I had x on either one of the ends, I would need to move it into the middle there. And then I need to make sure my x is by itself in the middle. So for this problem here, it tells us to solve and graph the solution set on a number line. So I notice that the only x I have is in the middle, so I need to get it by itself. So remember before when we solved equations and inequalities, what we did to one side, we had to do to the other. Well, because I have three parts, what I do to one part, I have to do to all of them to keep it the same. So I'm going to subtract that 3, so I got -2. My inequality sign's not going to change. Remember, it only changes when we multiply or divide everything by a negative number. My inequality sign didn't change, and I get 8. Then we still want to get x by itself, so we're going to divide everything by 2. So we get -1. We divided, but it wasn't by a negative number. It was by a +2. So then we got our x, our inequality sign didn't change, and we've got our 4. And so here is our solution as an inequality. Now, like we did the other day, we can write this in set builder notation. We could say x, the set of x's such that, and then just write your inequality there. So -x is less than, -1 is less than or equal to x, which is less than the 4. And close your set builder notation. We could also graph this because it said we had to graph it. And so remember, make sure you put your infinities, and I at least want to see the numbers that are involved here. And x is in between them, so that means we're going to graph where x is in between. We can see at the -1 it has an equal to, so we're going to use a bracket. And at the 4 it doesn't have an equal to, so we're going to use that parenthesis there. And then we could write our interval notation. We can see where our shading is at. We can see it goes from -1 to 4. The -1 had a bracket, and the 4 had a parenthesis. So we could write our solutions either in set builder notation or in interval notation, and then we also have our graph included here. Okay, now notice though on this one, notice that we shaded in between. What was the other thing that we shaded in between? Excuse me. And so it was an and statement. So these are what we call an and statement, which the other day we didn't call them and or statements. Okay, but this is an and statement. It is where we shade the overlap. Okay, so it's just like what we did the other day, where we shaded the overlap, and this is what we call that intersection. So it's got that symbol. Because if I took the 1 and I set it less than or equal to the 2x plus 3, I would have gotten -1 is less than or equal to x. And if I took the 2x plus 3 and I set it less than the 11, I would have ended up with x is less than 4. And then we'd have took each of those and would have graphed them individually. I'm going to this first one here, I'm going to flip it over so my x is first. And so we'd have said, well, at -1, we would have shaded this way. At the 4, we would have shaded this away. And so we could see that our overlap was the in-between. So it's the same type of problem. They're just able to write it in one problem because it is that and statement. All right, so let's talk about solving an absolute value inequality then. And so it says if U is an algebraic expression and C is a positive number, it says 1, the solutions of the absolute value of U are less than C are the numbers that satisfy that inequality they gave us there. Notice it's a compound inequality. So this would be what we call that and statement. Okay, it's where we will graph the overlap. It's our intersection. Now the solutions of number 2 says the solutions of the absolute value of u are greater than c are the numbers that satisfy that u is less than negative c or u is greater than negative c. This is what we call an or statement, okay? It is our union. It's, remember, where we graphed everything, because it can be true in this one or it could be true in that one, okay? Now, I use the inequality signs to help me remember which one is which. So, remember that this symbol is really the less than symbol, right? But I'm going to call it a less than symbol because it's our and, okay? The second one here is, I wrote it wrong, sorry, this symbol, which is a greater than symbol, but I'm going to call it greater, okay, because it's an or statement. So it's less than or greater, and that helps me remember, is it an and statement or an or statement? And then it says the rules are valid whether it's less than or equal to, greater than or equal to. It'll work the same. So let's look at this. Now, the only thing I did forget to mention here is that if it has, notice on both of these, in order to use the less than or the greater, our absolute value piece has to be first, okay? So if it's written where, like this next example we're about to do, where the absolute value is on the right-hand side, we're going to have to flip it over. So, but just like we did before, the first thing I'm going to do is make sure, is my absolute value piece by itself? And it is. We don't have anything being added or subtracted to it, being multiplied or divided with it, so it's by itself. Now the only thing is it's on the right, so I'm literally just going to flip this over. So I got 6 minus 3x, and then we got that 18. I notice my arrow is pointing towards the 18, so I'm going to make it point towards the 18 again. All right, now if we can simplify inside those absolute value signs, I recommend that you do it. Okay, I would simplify that before you try to split them. So just like when we solve the equations, we're going to take that absolute value and we're going to take the positive of what's inside with the inequality in the 18, and we're also going to take the negative of what's inside with our inequality and the 18. Because remember, what's inside those absolute value bars can be a positive or a negative number. All right, so we're going to solve this one. So let's distribute the positive there. So we have 6 minus 3x. It's greater than 18. When we distribute there, guys, we're only working on one side, so we don't have to worry about does our sign change, okay? It only changes when we're doing things on both sides. So then I'm going to solve for x. I'm going to subtract the 6. So negative 3x. My inequality, and 18 minus 6 is 12. Divide by the negative 3. And so we get x. Now we divide it by a negative, so our inequality is going to flip, and we get negative 4. Now, I forgot to ask at the beginning, but look at it once we flipped it. Is this a less than or a greater? This is a greater. So this means that this is an or statement. So I'm just going to go ahead and write or. And we're going to do the same thing to the second one here. So let's distribute that negative. So we get negative 6 plus 3x. Our inequality in 18, then just solve for x. So add the 6, so 3x, our inequality in 24, and then divide by 3. So x, our inequality is not going to change because even though we divided, it was by a positive 3, and we get 8. So here is our answer as in inequalities. Typically, we don't see them written in step builder notation, but we could go ahead and graph this. So if I'm going to graph this, I got my infinities. I got to have a negative 4 and an 8. Now remember, because this is an or statement, we graph everything. So if it makes the first inequality true or the second inequality true, it's going to be part of our answer. So let's see, it tells us that x is less than negative 4. So that means from negative 4, I'm going to shade towards negative infinity. And it's less than, it doesn't have the equal to, so we're going to use a parenthesis. The other one says or x is greater than 8. So the 8, we're going to go greater than, so we're going to go towards positive infinity. And the 8 doesn't have an equal to, so it's also going to have a parenthesis. But we can write this in interval notation though now. So we can see our two shadings. So my first one is from negative infinity to -4. We know the -4's got the parenthesis. We can see it in our graph. And remember, infinities always have parentheses. But then we're going to put our union symbol. And we can see our next shading here is from 8 to infinity. We can see the 8 has a parenthesis by the graph. And remember, infinities always have parentheses. And so there's our interval notation. And then up here we did do our graph. Now, I know the next slide is blank, but I'm going to make up a problem and with some other stuff that we need to talk about. So, what if I had like 2 times the absolute value of 2/3 x plus 3/4 was less than, let's say, 10. Okay, so I need to be able to get the absolute value part by itself first. So that 2 right there has got to go. Well, that's 2 times. So to get rid of it, we're going to do the opposite of times, which is divide. And so, again, if it had been negative, I'd have to watch my signs. So we've got the absolute value of 2/3 x plus 3/4 is less than 5. Now, I know you don't like fractions, and we have a choice here. We can go ahead and split it and then get rid of the fractions, or go ahead and get rid of the fractions first. So, remember, to get rid of a fraction, the only part that I'm having trouble with on this one, the 2/3 x, is the 3 on bottom. If the 3 was gone, I would just have a 2x. What will make that divided by 3 go away? Well, remember, do the opposite. So we're going to multiply by 3. So I'm going to write it out here. But I also have this 3/4 here. So I need that 4 on bottom there to go away. So I need to also multiply by a 4. Here I have a 5, which is the same as 5/1. I'm not worried about it. It's not a fraction. But it's still going to get multiplied like everything else to keep it equal. So we're going to multiply every term that we've got here by 3 times 4. I have 3 different terms, and they're all going to get multiplied by the 3 times 4. So for this first one here, when I multiply, the 3 will cancel, so it just leaves us with the 4 times the 2x. And so we get the absolute value of 8x plus, the second one here, the 4's were canceled, so we're just left with the 3 times 3, which is 9. Close your absolute value, your symbol, and then 5 times 3 times 4, that's 60. Now we don't have any fractions. We're ready to solve our absolute value part. So we're going to split this. We're going to take the positive of what's inside is less than 60. And we're going to take the negative of what's inside is less than 60. Now remember, this is a less than. So, and I forgot to ask to make sure we had absolute value on the left, and we did. All right, so this is a less than, so that means this is an and statement, which means when we graph this, we're going to graph the overlap, which also means we saw in that first example that we'll be able to write our answer as some number and then less than, maybe with an equal to, x less than some number. And of course, if there's an equal to, we'll have to look at the inequality to see if we need to put it on these inequalities. And this is our intersection as well. All right, so let's solve both of these. So I'm going to distribute that positive. So my 8x is less than 51, and then divide by the 8. And so we get x is less than, I think it's 375. Let me check though. D1 divided by 8. Yeah. Okay, and so we're going to solve the second one here. So distribute your negative. And then solve for x. And divide by your -8. So my inequality sign is going to flip because we divided by a negative. And 69 divided by negative 8 is negative 8.625. Now, they're not going to write our answer like this. I'm not going to box it. I'm just circling it. Okay? But we can take and we can write our answer now as a compound inequality. So we know it's going to be less than x, less than something. Because the way it's written, it's always our smallest number first. So which one is smaller, the 6.375 or the negative 8.625? Well, the negative number is smaller, so put it first. And you can see, you can look at the inequality we solved at the bottom. Notice the arrows pointing towards the negative 8.625. And when I write my compound inequality, the arrow's still pointing towards it, okay? And then we're going to write the larger one at the end, so that's 6.375. And so we can see on that inequality, the smaller side is towards the x. And we can see that's the same exact thing there as well. So we wrote it correctly. Then you just got to make sure and check, do you need an equal to? We'll look at your inequalities at the bottom. Do they have an equal to? They do not. So here is our compound inequality, which then they could write this in set builder notation. They could write it in interval notation. So negative 8.625, comma 6.375. And neither one have an equal to, so they're both going to get a parenthesis. And then, of course, we could graph these. So negative infinity to infinity. My negative 8.625, my 6.375. We know x is between them, so we're going to shade between them. And I can see from my interval notation that we've already decided they're both going to get parentheses. And so there would be our graph. All right, so the only other thing you have to watch out for is what if, when I get this, let me back up there, sorry. What if it's, when I get to the end, if I have like x is less than negative 7 and x is greater than negative 7. So you'll notice when you go to write that compound inequality, you're going to be like, man, they're the same exact number. Remember, because this is an and, this is where they're supposed to overlap. So just think about this one. If we tried to graph it, we got our infinities, and the only other number we have there is a negative 7. All right? So I'm going to use the open and closed circles right now to see this one. So if I graph the first one on top, I would have an open circle, and it would go towards negative infinity. If I graph the second one on bottom here, I'd have an open circle, and it would go towards positive infinity. Look at it. They don't overlap anywhere, because even the open circles means they're not included. So if you have something like this, you're going to end up with no solution. Now, if it was, let's use the same numbers, but this time I'm going to change the inequality sign just a little bit here, okay? This time it's got that equal to. And I'm going to use the graph right above to show you. So the only difference is now we would have that closed circle. And see, because we have that closed circle in that negative 7, that means it is equal to at the negative 7 on both of them. Negative 7 is the only place that it overlaps. So my answer would actually be where x is equal to 7. Or negative 7, excuse me. All right, so everything else I think you should be good for, so good luck.